Lana is making a fruit juice. She takes out a tray of ice cubes from the freezer and places it on the table while preparing the juice. When Lana takes out the ice cubes from the tray to put into her fruit juice, some of the cubes have already melted. This can be due to the hot weather outside. After using the ice cubes, Lana fills up the tray with water and puts it back in the freezer. After some time, the water cools and becomes ice. Matter such as solid, liquid, and gas expands when heated and contracts when cooled. Water, when left in a hot environment, expands and the volume increases. But when water is placed in a cold environment, it contracts and the volume decreases. A gold bar becomes bigger when it is heated. When it cools, it becomes smaller again. The mercury in a thermometer expands when it is hot. The expansion of the mercury causes the level of the mercury to rise. When it is cooler, the mercury contracts and the level falls. Gases behave in the same way as solids and liquids when they are heated and cooled. The dented table tennis ball can be returned to its original shape when it is immersed in hot water. The air inside the table tennis ball absorbs heat from the hot water and expands. When the air expands, it pushes the inner wall of the ball outwards. The ball then returns to its original spherical shape.
As you can see, the ball can fit through the ring, but when we use a torch to heat it up, the ball can't fit through it anymore. When you heat up items, the atoms move faster and need more space. What would happen if we put the ball into a glass of cold water? As you can see, the ball can fit through the ring.
If you put liquid nitrogen on a balloon, the atoms move slower, need less space, and this is called contraction. When the warmer atoms from the ground and air hit the balloon, the atoms inside the balloon heat up and they expand.
Do you think that the rails bent because of thermal expansion? If yes, then you are absolutely correct. A railway track is made up of a number of rails joined to each other. These rails are usually made up of steel. Steel expands on heating and contracts on cooling. When the rails are joined to one another without leaving any space for expansion, the rails bend due to thermal expansion and the train goes off the railway track. To avoid this, the rails are not joined together firmly. Instead, each rail is connected to the other in such a way that a small gap is left in between them. These small gaps provide space for easy expansion of the rails, which happens during summer, as well as due to continuous friction between the train wheels and the rails. Hence, these small gaps prevent the rails from bending, preventing any kind of accidents.
The sagging wire. The apparatus consists of a metal wire hung between two stands. Curtained ring is made to pass through the wire. When the wire is heated, we find that the ring begins to sag in the wire, indicating the increase in the length of the wire. Bimetallic strip. A bimetallic strip is made from two thin strips of metal, which expand by different amounts when heated. Often brass and steel are selected. The two pieces are welded. When heated, brass expands more than steel, bending the strip into an arc.
Automatic fire alarm. An automatic fire alarm in a building's security system is a heat detector that responds to the heat from a fire by setting off an alarm. Some heat-detecting fire alarms rely on a bimetallic strip as the temperature sensor. This strip responds to heat by closing a normally open electrical circuit to activate the alarm. Working. The bimetallic strip in a fire alarm is made of two metals with different expansion rates bonded together to form one piece of metal. Typically, the low expansion side is made of a nickel-iron alloy called INVA, while the high expansion side is an alloy of copper or nickel. The strip is electrically energized with a low voltage current. When the strip is heated by fire, the high expansion side bends the strip toward the electrical contact. When the strip touches that contact, it completes a circuit that triggers the alarm to sound. The width of the gap between the contacts determines the temperature that will set off the alarm. Demonstration of cubicle expansion in liquids.
The apparatus consists of a glass tube fitted with a cork having a hole. A narrow glass tube is passed through the hole such that it fits tightly. Water is filled in the bottle to its neck and is colored with potassium permanganate. On heating, one finds that the water begins to rise in the glass tube, showing that liquids undergo cubicle expansion on being heated.
Thermal expansion.
The expansion produced in a matter when heat is supplied to it is called thermal expansion.
Linear expansion. In this expansion, when a solid is heated, there is a change in its length alone. Superficial expansion. In this expansion, when a solid is heated, there is a change in its surface area alone. Cubicle expansion. In this expansion, when a solid is heated, there is a change in its volume.